Okay, so today we're looking at day 2 from yesterday's topic 5, operations with radicals. We're going to be looking at multiplication division. We looked at multiplication before, now we're going to be looking at multiplication when there are binomials involved. So 4 root 3 plus 5 root 2 times 3 root 2 minus 6. We just use the distributive property, the same thing we do whenever any binomials are involved. So 4 times 3 is 12. Root 3 times root 2 is root 6. For the next one, 4 times 6 is 24, and then we still have the root 3. For the next one, 5 root 2, 3 root 2, so 5 times 3 is 15. But root 2 times root 2 is root 4, which is just 2. So square root 2 times square root 2 is just 2. So it ends up being 5 times 3 times 2, which is 30. And then 5 root 2 times negative 6, which is negative 30 root 2. None of these can be combined, okay? If we look at closely, square root 6, square root 3, constant, square root 2. None of these, well actually they're all constants, but none of them can be combined, simplified by combining. Alright, so because none of them have the same radicand. This has 6, 3, this doesn't have 1, and this has 2. So none of these can be combined, so we'll just leave it there. Now, for number 2, you might notice that 2 root 3 plus square root 2 times 2 root 3 minus square root 2. They're the exact same. The only difference is that the root 2, that it has a plus sign in between them, and this one has a minus sign. These are called conjugates. Okay? The reason they're called conjugates, they're the same thing, except this is plus and this is minus, because when we multiply them together, using the distributive property, they will become a whole number. Okay, so let's see how that happens. 2 times 2 is 4, and root 3 times root 3 is 3, so 4 times 3 is 12. 2, so this is negative 2 root 6, because root 3 root 2 is root 6. Let's move on to this one. So that's positive 2 root 6, because 2 times 1 is 2, 3 times 2 is 6. And then root 2 times root 2 is just 2, so that's just minus 2. Now this is why this happens, because this minus 2, 6, and this plus 2 root 6 cancel out, and we just have 12 minus 2, which is 10. So this reduces to a whole number, just 10, no radicals. They're called conjugates for this reason. Reduces to 10. Now we're going to use this idea to help us do division. Division works very similar to the way that imaginary numbers worked when we divided imaginary numbers. So dividing, multiply the numerator and the denominator by the conjugate of the denominator. So you're really just multiplying by 1 when you're doing this. Alright, so let's say that we want to divide 5 over root 2 plus 3. So the first step here will be to multiply the numerator and denominator by the conjugate of the denominator. Denominator is square root 2 plus 3. So the conjugate would be the same thing, except with minus in between. So this would be root 2 minus 3 and root 2 minus 3, which is just 1. So we'll multiply the numerator by that, and we'll multiply the denominator by that. So 5 times root 2, 5 root 2. 5 times negative 3, negative 15. And we actually want these, we want the negative 15 to come first. So let's put the negative 15 first. So it's negative 15 plus 5 root 2. Over, root 2 times root 2 is just 2. Root 2 times negative 3 is negative 3 root 2. 3 times root 2 is positive 3 root 2. And 3 times negative 3 is negative 9. So these cancel. We got 2 minus 9, which is negative 7. So in the numerator we have negative 15 plus 5 root 2. In the denominator we have negative 7. Alright, now the last thing is to split the denominator between the two of them. So the first term is negative 15 over negative 7, which is just 15 over 7. And the second term is 5 root 2 over negative 7, which is negative 5 root 2 over 7. And this would be the division of number 3, 5 divided by root 2 plus 3. 15 over 7 minus 5 root 2 over 7. Same exact way we did imaginary numbers for division. Alright, number 4. 4 plus root 2 over square root 2 minus 3. Alright, so we want to turn that denominator into a normal number, which means that we need to divide it by the complex conjugate, which is square root 2 plus 3. And we also need to do that to the numerator, square root 2 plus 3. So we'll use the distributive property. So 4 times root 2, 4 root 2, 4 times 3, 12. Root 2 times root 2 is 2, and root 2 times 3 is 3 root 2. The denominator, square root 2 times square root 2, is just 2, plus 3 root 2, because times 3. Negative 3 times root 2 is negative 3 root 2, and negative 3 times 3 is negative 9. Alright, well those cancel. So the numerator, 12 plus 2 is 14, and 4 root 2 plus 3 root 2 is 7 root 2. And this is all over 2 minus 9, which is negative 7. Okay, so we'll split the denominator, we'll split the negative 7. We got 14 over negative 7 minus 7 root 2 over 7. Okay, I just put the minus sign here instead of under here. It's the same thing. And you know what? Well, it's going to work out in the end, so I don't need to do it for the other one. But I could put the minus sign out front. But 14 divided by negative 7 is negative 2. And 7 divided by 7 is 1, so this is negative 2 minus root 2. That's what we get for number 4. 4 plus root 2 over root 2 minus 3 simplifies to negative 2 minus root 2. Alright, homework for this one, page 85, 19 through 23, page 86, 31, and 34.